Section 9.1 is on page 354, talks about polynomial and rational inequalities. Not equal, less than, greater than. So if I'm glancing at this problem, I'm trying to figure out if this is the graph of f of x, where is f of x less than 0? Doesn't less than 0 mean it's negative? And where do we notice that it's negative? We notice that it's negative, so f of x is the y, it's negative, right? You know what? Let me use a different. It's negative right there and right there. So again, since you're measuring the y, your answer is always in terms of x. You would say it's negative from negative 1 to 1, union with 2 to infinity. The reason I'm not including those, because it says strictly less than. And if I look at where's the graph bigger than 0? Bigger than 0 is right here and right here. This is where y is bigger than 0. So here I would say, where would this be bigger than 0, meaning positive? It's positive from negative infinity to negative 1, union with 1 to 2. I'm sorry. Greater than or equal, so they're included. If I look at a rational function, it's a bit messier to see, but same idea. If I look at where's the graph above the x-axis, y positive, y is positive here, y is positive here, and y is positive here. So, positive, that would be from negative infinity to negative 1, union with negative 1 to 1, union with 3 to infinity. And if I was to say, where's the y negative? Well, it's negative right there and right there. We would say it's negative from 1, less than or equal to 0, right? So it's including the 1 to 2, union with 2 to 3. And there it is. Now, I could do every problem graphically, and I strongly suggest you do that. There are two techniques of doing this, algebraically and graphically. I suggest that you graph each of those. And since you're an expert on graphing those, because you took math 3, you're in good shape. This is a polynomial. The zeros are 5, 1, 2, 3, 4, 5, negative 2. If I let x equal 0, I'll get negative 20. Assume this is negative 20. And this behaves like x to the third, left to right. The multiplicity on this 0 is a 2. That means it must look like a parabola. To make it look like a parabola, you have to come back down. And the multiplicity on this is a 1. You want to make it look like y equal x to the 1. Like a straight line, so to speak. Oops. That's good enough right there. So if I was to say, can you tell me where's this graph bigger than 0? Meaning positive. Right there. You would say, if you use the graph, you would say not included from 5 to infinity. Done. Alternative is for you to use a number line. Figure out where each of those equals 0. Well, where does that equal 0? At 5, this is 0. 1, 2, 3, 4, 5. And negative 2. So I have 3 regions. Here, here, and here. Pick a test point in negative, to the left of negative 2, say negative 3. Negative 3 minus 5 is negative. And since this is being squared, it's always positive. Negative times a positive is a negative. Pick a point between negative 2 and 5. Let's say you pick, and those are not included, right? Because of that. If you pick 0, 0 minus 5 is negative, and that's always positive. Negative times a positive is a negative. And if you pick 6, 6 minus 5 is positive, times a positive is a positive. You want to know where is this bigger than 0? From 5 to infinity. I suggest you use the graph because it's a lot faster, but I want to show you both of those techniques because you need to be able to do something like that. If I look at the next graph, well, I know how that graph look like because, you know, again, I took college algebra. I'm a pro at graphing. The zeros are -1, -2, and -3. If I put 0 in for x, I'll get 1 times 2 times 3, which is 6. I always go 2 units no matter what that number is and label it. This behaves like x cubed. So since the multiplicity is a 1 on each of those, you're going to make it like a straight line, and straight line. The last piece. Third time will be a charm, or is that the fourth time? So that's sort of how the graph looked. Well, what do I want to know? I want to know where's this less than 0, negative. It's negative there and there. So it is negative from -infinity or equal to negative, so this is -1, -2, and -3 to -3, union with -2 to -1, done. You could also, if you wish, make a number line and say, where does this less than or equal? So I need a -1 included, a -2 included, and a -3 included. You're going to pick a test point there, 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 and there. And you could do that. -5, for example. Negative, negative, negative. 3 negatives multiplied will give you a negative. If you pick -2.5, -2.5 plus 1 is negative. -2.5 plus 2 is negative, but -2.5 plus 3 is positive. So you could do that. Pick a point there and pick a point there, and they turn out to be looking for negative right there and right there. And you could always do that. This problem, I'll get everything on one side, 0 on the other side. We never divide in this case. If I factor a 3x squared out, I'll have an x plus 5. Again, I know how to graph this. The intercepts are 0 and -5. This behaves like an x cubed. We know how an x cubed looks like. Left to right, the zeros, this is multiplicity 1, so this is going to look like a straight line around that 0. And do you see how this looks like a parabola? That better be a 2 or a 4. So what do I want? I want to know where is this less than 0. Only right there. So that is from -infinity to -5, not included, correct. Done. You could do this graphically, again. Don't recommend, algebraically. Graphically is a lot more efficient, I think. Pick a point right there, say -6. This is always positive, so -6 plus 5 is negative. Let's say -4. -4 plus 5 is positive. And if you pick 3, 3 plus 8 is positive. Again, the fact that this term is being squared all the time is always positive. It doesn't change anything. I want to know where is this less than 0. And since it's strictly less than, it's not included. And there's the answer. Rational functions, the same way. No difference. I will graph that. We can graph anything, right? So, what do we have? Vertical asymptote x equal -1. Horizontal asymptote y equal 1. Y-intercept at 0, -3. Okay, you know what? I'm going to rescale the whole thing. Should have did that from the beginning. X equal -1. I'm going to say that's -1. Y equal 3. I'm sorry, y equal 1. The graph must cross at 0, -3. and the top equals 0 when x equals 3. So the graph looks like this and this. And what is it that I want? I want to know where is this positive above the x-axis. I would say my answer would be negative infinity, not included, to negative 1, union with 3 to infinity. Another way of doing this problem is for you to make a test line. There's nothing wrong with that. So, where are the zeros? 3 and negative 1. Negative 1 I can never include because it's in the denominator, and this I can't include. I'll pick negative 2 as a test point. Negative 2 minus 3, that's negative 5. Negative 2 plus 1 is a negative. 2 negatives divided will yield a positive. If I pick 0, 0 minus 3 is negative. 0 plus 1 is positive. Negative divided by a positive is a negative. And if I pick 4, 4 minus 3 is positive. 4 plus 1 is positive. I want to know where is this bigger than 0. It's bigger than 0 from negative infinity to negative 1 and 3 to infinity. And the last problem, as is, it's very hard to do. Instead, what I'll do, cross multiplying is not an option because this is not a linear inequality. You treat a linear inequality like an equal unless you multiply or divide. Then you switch the symbol. This is not the case. Reason for that, this is not a linear inequality. So you multiply top and bottom by x minus 4, and you end up with all over x minus 4, x plus 2, minus x plus 4. You end up with a 6 over x minus 4. And how does this work? If I want to do the graph, I could. Vertical asymptote at 4. I know there's a horizontal asymptote at y equals 0. If I put 0 in for x, I'll get negative 6 over 2, which is negative 3 halves. There's a piece, and it's like y equal 1 over x shifted 4 units to the right. What do I want to know? I want to know where is this graph bigger than or equal to 0. Bigger than or equal to 0 right there. That is from 4 to infinity. And if I decided to take the test point approach, nothing wrong with that. The top can never equal 0. The bottom could equal 0 at 4. And if I pick a point to the left of 4, say 0, put it in there. The top is positive 6. That's positive over a negative is a negative. And if I pick 5, 6 is positive over 5 minus 4 is positive. That's a positive. I want to know where's this greater than or equal to 0. That would be here. And did you notice I'm not including that? Why am I not including that? Because x equal 4 is in the denominator. Even if it says greater than or equal to, you can't include that. And you could do these. You don't have to do them both ways. You could do them one way. Your homework is section 9.1 on page 358, number 5, 7. And I want you to do 9 through 47 every other odd. You could do the graphs. That's fine. It's a good practice.